In this section, we learn about the different ways in which bolts are connected to the rest of the assembly. When bolts are represented as line bodies, we often use beam connections, and when bolts are modeled as solid bodies, we use contact connections to define the interaction between the bolts and the mating parts. So now, let's consider a model of a wall-mounted bearing which consists of a bearing sandwiched between two brackets. The two brackets are bolted to each other and the entire assembly is mounted on the wall using bolts. In this model, we do not use nuts to tighten the bolts, but instead, threads are cut into the lower bracket and the wall, which mate with the bolt threads. In this workshop, we will learn how to define all the required contact pairs in the model and also go through a few tips for debugging certain common issues that arise when using contact. So let's get started. For this example, we will perform a static structural analysis. The first step is to check the units. We are going to use metric units for this example, and it is correctly set. The next step is to define material properties. Double-click on the engineering data. We see that structural steel is defined by default. For this model, we will only use structural steel. So go back to the workbench window. The next step is to import the geometry. For that, right-click on geometry and import geometry of bracket.sc doc file. Now, let us open that geometry in mechanical by double-clicking on the model. Again, check the units to make sure they are consistent with what we used in the workbench. Here we have 8 bodies and all of them are independent bodies. That is, they are not sharing any topology with each other. This means that we need to create contact connections between these bodies so that they can interact with each other. The next step is assigning materials to the bodies. Here, we only have one material and by default all the bodies are assigned structural steel. We will leave that unchanged. Next, we will create named selections to make the process of defining contacts or boundary conditions easier. For that, right-click on the model and insert named selection here. First, let's create a named selection for all the bolts. Make sure the select body option is active and select one of the bolts. Then go to the selection menu and choose Select all entities with the same size. So that selects the 2 bolts. Since we want to add 2 more bolts, we can either select them by pressing Ctrl and selecting the 2 additional bolts one by one, or we can select them from geometry tree. Right now, our geometry has limited bodies, so we can choose the bolts manually. Let us call this named selection bolts. Now different portions of the bolt surfaces have different types of contacts with the mating components. So let's create different named selections for these different bolt surfaces to help with the contact definitions. Make sure the select face option is active. First, we will create a named selection for the lower surfaces of the bolt heads. So select one such bolt head face and then under the size option, choose Select all entities with the same size. This selects the lower surfaces of the 4 bolt heads. Now we can right-click, choose Create Named Selection and call this bolt heads. Following a similar procedure, create a named selection for the shank surfaces called bolt shanks and another one called bolt threads consisting of the threaded portions of the bolts. Now we need to identify the corresponding surfaces on other components that will come in contact with the bolt faces we just defined. We will first create a named selection for the imprints that will come in contact with the lower faces of the bolt heads. If we zoom into one of the slots, we notice that the inner surface of the slot in the bottom bracket has been divided into two parts using imprints. One surface which will have frictional contact with the bolt shank and another which will have bonded contact with the threaded portion of the bolt. We will create a named selection for the inner faces of the holes in the top bracket and call it bolt shank imprints 1. For the inner faces of the slots in the bottom bracket, we will create a named selection called bolt shank imprints 2, consisting of faces which come in contact with the bolt shank, and another named selection called bolt threads imprints, consisting of faces which come in contact with the threaded portion of the bolts. Now we are done with creating the named selections for bolt faces and the corresponding mating component faces which come in contact with the bolts. Next, we will create named selections for different faces of the bearing. Make sure the select face option is active and the selection mode is box select. When using the box select option, if the box is created from left to right, then only entities which are fully enclosed in the box are selected. On the other hand, if the box is created from the right and dragged to the left side, all entities which are even partially enclosed in the box get selected. Suppose we want to select these four faces of the key on the top. If we create the box from right to left, only these four surfaces get selected. Then we can right click and create a name selection called key top. Following a similar procedure, create a named selection for the surfaces of the bottom key called key bottom and a named selection for the inner surfaces of the slot in the top bracket called key slot top. When we use the box select option to create a named selection for the key slot in the bottom bracket, we end up selecting an additional face. To remove this from the current selection, change the selection mode to single mode, press Ctrl and click on that extra face. Now we can call this named selection key slot bottom. Following similar procedure, we create a named selection for outer faces of the bearing called bearing outer, a named selection for the lower surface of the top bracket which comes in contact with the bearing called bearing imprint top, a similar one for lower bracket face called bearing imprint bottom. We also create named selections for the faces of the top and bottom brackets that are in contact with each other and call them bracket top and bracket bottom. Lastly, we create named selections for the surfaces of the bracket mount and the wall that are in contact with each other and call them bracket mount and bracket mount imprint respectively. With this, we have created all the named selections that we need. Although this process of creating named selections may seem a bit tedious, it makes defining contact very easy and systematic. The next step is to create contact connections between various surfaces. When we go to connections, we observe that a set of bonded contact connections has been created. These connections or contacts are created automatically based on the default tolerance value defined for all the bodies. However, since all the contacts in this model are not bonded, we will delete all these auto-generated contacts and create contacts systematically from the named selections that we defined. So first, we will create contact between the bolt heads and the mating components. To do this, right-click on Contact under Connections and choose Insert Manual Contact Connection. Select lower face of a bolt head as the contact side and the corresponding imprint on the top bracket as the target side. Let's define frictional contact between these two surfaces. Let's take a moment to discuss why we are using imprints on the mating components. Since we are defining frictional contact between the bolt head and the corresponding imprint, and since frictional contact is non-linear, it is important to have equally fine mesh on both the contacting surfaces. If we do not use imprints, the entire mating component will need to have a fine mesh like that of the bolt, which unnecessarily increases the computational cost. So, we use imprints to demarcate regions on the mating components where a finer mesh is required. So let's change the contact type to frictional and define a coefficient of friction of 0.1. Once this contact has been created, to create similar contact pairs between the other bolt heads and mating parts, we will go to the Automation tab and click on Object Generator. For the contact side, we will choose the named selection bolt heads, and for the target side, we will choose bolt heads imprints. For the tolerance between centroids, let's set the maximum to 0.1 meter and then click on Generate. We will see that 4 new contact pairs have been created with similar properties. Next, let's create contact between the bolt shank and the shank imprints. This is the bolt shank. An easy way to define the new set of contacts is to duplicate one of the existing frictional contacts and just redefine the target and contact sides. For the target side, select the bolt shank surface, then right-click and invert visibility. For the contact side, select inner surface of the hole in the top bracket. In order to replicate this contact on other bolts, we use Object Generator with bolt shanks as the target side and the corresponding imprints on mating components as the contact side. Following similar procedure and by using Object Generator, we define frictional contact between bolt shanks and the holes in the top bracket, another set of frictional contacts between bolt shanks and the slots in the bottom bracket. Then, we define a set of bonded contacts between threaded portion of the bolts and threaded portion of the slots in the bottom bracket, since we don't expect to have relative motion between these two sets of surfaces. Finally, following similar procedure, create frictional contact pairs between various mating components. We need to define frictional contact between the key on the bearing and the corresponding slots in the top and bottom brackets. Frictional contact also occurs between the top and bottom bracket, between the bearing and the two brackets, and finally between the bracket and the wall. All the named selections we created earlier come in handy.